Okay, we've discussed ionic compounds, covalent compounds, and we touched a little bit on organic, so let's go a little bit further into organic compounds. Your pharmaceuticals are going to be organic compounds, things like aspirin and insulin. And you'll notice that all organic compounds contain a carbon. Most large organic molecules are polymers, which is a repeating unit. So some natural ones are proteins, nucleic acids. So these things right here are going to keep repeating in a chain. Your synthetic ones are things like nylon, Kevlar. So this piece right here from this end, all of these carbons, and then this amine group, this is going to keep repeating over and over and over again. So all organic compounds contain a carbon, and the simplest organic compounds are things like hydrocarbons. It's a combination of hydrogen and a carbon. If they are saturated, the hydrocarbon will only contain single bonds. That means that each hydrogen has all 4 bonds that it can form. And if it is unsaturated, the hydrocarbon will have at least 1 double or triple bond somewhere between the carbons. So when you name an organic compound, you're going to use prefixes, and those prefixes are going to tell you how many carbons are in the compound. So meth is 1, 2 is eth, 3 is prop, 4 is bute, 5 is pent, 6 is hex, 7 is hept, 8 is oct, 9 is non, and 10 is dec. So like propane, you would have 3 carbons there, and then the ane indicates what type of bonds and whatever functional group is there. Butane, same thing. The suffix is going to be determined by the series of the organic compounds. So alkanes are going to only have single bonds. Alkenes will have 1 or more double bonds between the carbons. And alkynes are going to have 1 or more triple bonds between the carbons. There's also cyclic structures or rings that can form. The most common is benzene. This is one way of drawing it, but typically in organic you leave the carbons out, so you would know that each bend is a carbon. Now your functional groups are going to be atoms or a group of atoms that always react in a certain way. And you're going to have R and R prime representing any carbon chains or carbon rings hanging on that functional group, or have that functional group hanging off. Functional group is going to be attached to the R or the R prime chain. For example, if you have R with an OH, that OH group is making it an alcohol. So if you had CH3OH, that would be methanol because there's 1 carbon. If you have an R, an oxygen, and then an R prime, that's going to be an ether. And if there's an NH2, it's going to make the compound amine. So if you have CH3NH2, that is a methylamine.